The universe is amazing, right? But its sheer size makes leaving our galaxy feel, well, impossible.
So let's just imagine a trip to Andromeda. That's our closest galactic neighbor, 2.5 million light-years away.
Okay, with the ships we have now, that trip would take, wait for it, 94.5 billion years.
And even at light speed, you're still looking at a 2.5 million year journey. Just wow.
But what if there was a shortcut? A way to make that trip in just a few months?
This is where wormholes come in. Yeah, kind of like in the movie Interstellar.
But here's the thing, this isn't just sci-fi. The whole idea is rooted in actual physics.
It actually started with Albert Einstein's famous field equations all the way back in 1915. Basically, these equations show how huge things like stars literally bend the fabric of space and time.
And just like a simple math equation, Einstein's equations can have more than one right answer.
Black holes were one possible answer. Another was something called an Einstein-Rosen bridge. Yep, a wormhole.
So, how would this even work? To get our heads around it, let's simplify things a bit.
Picture a piece of paper. You can just fold it to bring two distant points right together. A wormhole would do the same thing, but by bending our 3D space through a fourth dimension.
So what could cause a bend that big? You'd need an absolutely insane amount of gravity.
The only thing we know of with that much gravity is a black hole. That's your entrance.
Okay, but what about the exit? Another black hole would just be a one-way trip to nowhere. The solution, at least in theory, would have to be the exact opposite of a black hole.
We're talking about a white hole, something that doesn't pull stuff in, but pushes everything out.
There's just one tiny problem. No one's ever seen one, and they might break the laws of physics.
So for now, actually traveling through a wormhole is still just a really cool idea.
But get this, in 2015, scientists actually made something they called a magnetic wormhole in a lab. Now, it only bent a magnetic field, not the fabric of space-time itself, but still pretty cool. And this isn't the only idea out there. Physicists are looking at other ways to warp space-time.
So you have to wonder, what other secrets for cosmic travel are hiding in Einstein's equations?